Hi everyone, I am Dr. Chaudhary, Assistant Professor, Department of Mathematics working in RMD Engineering College. In this video, I am going to share the ideas about algebra and number theory. Especially, the topic is fields. Before we are going to see the fields, let us see what is the algebraic structure. See the definition, a non-empty set with one or more binary operations defined over it and satisfying certain laws of binary operations is called algebraic structure or an algebraic system. A non-empty set means a set should be non-empty. At least it has one element with one or more binary operations. Among the operations plus, multiplication, division and subtraction, we are taking any two operations. We have certain laws. A set should satisfy these laws of under the binary operation, then it is called algebraic structure. See the example, r comma plus comma dot. R is the set of real numbers under the binary operations plus and dot. See r comma plus comma dot. For example, I am taking any two elements belongs to the real number. Okay, sum of these two numbers and the product of these two numbers both belongs to the same real number. That axiom is called closure axioms. Here I am taking 7 and 9. Sum of these two numbers 16. Product of these two numbers 63. Both are real number. So if any two numbers from the set under plus under dot satisfy this condition, it is called closure axioms. Okay, if any set satisfy these closure axioms, it is called groupoid. That is, r comma plus is groupoid or quasi group, or r is a quasi group under dot. Okay. Next, I am taking three elements from the set. Okay, 7 plus, adding second and third first, then adding first and second, then I add with third. Like that, I multiply second and third, then I multiply with the first one, then I multiply first and second, then multiply with the third. Okay, if the any three elements satisfying under this condition, it is called associative axioms. Here I am taking 7 plus 9 plus 10 equal to 7 plus 9 plus 10 equal to 26, and 7 into 9 into 10 equal to 7 into 9 into 10 equal to 630. Anyway, both answers belongs to the same real numbers. If any set satisfies closure axioms and associative axioms, then it is called semigroup. Okay, here R is semigroup under plus and R is semigroup under dot. Now, I am taking any number also 0 belongs to R. Then 7 plus 0 equal to 0 plus 7 equal to 7. Okay, I am taking any number. When I add the number with 0, I am getting the same number. Also, I am taking 1 belongs to R. I multiply 7 with 1 and 1 with 7. I am getting the same answer 7. Okay, so that type of property is called existence of identity. If one set satisfies closure, semigroup, associative property and existence of identity, then it is called monoid. So here R is monoid under plus, R is monoid under dot. I am taking 7 minus 7, 1 by 7 belongs to the real number. See, 7 minus 7 or minus 7 plus 7 equal to 0. 7 into 1 by 7 or 1 by 7 into 7 equal to 1. So, the also 0 and 1 belongs to R. See what happened? I add the number 7 with one number, I am getting the answer identity. And also, I multiply 7 with one number, I am getting the answer identity in R. So, if any number add or multiply with one number, if you are getting identity means, then the axiom is called existence of inverse. Okay, if any one set satisfies closure, associative, existence of identity and existence of inverse, then it is called group. Here R is group under plus and R is group under dot. Now we come to this one. I am taking any two numbers. If I am adding 7 plus 9, first and second or second and first, both result is belongs to the same number. Also 7 into 9 or 9 into 7. Multiplying the first and second or second and first, both answers belong to the same set. If the set satisfies this condition, it satisfies the commutative property. Now I come to the point. If any set satisfies closure, associative, existence of identity, existence of inverse and commutative, then it is called abelian group. Here R is an abelian group under plus, R is an abelian group under dot. Okay, now in the set R comma plus comma dot, R comma plus is an abelian group. It satisfies the 5 axioms with 0 as the identity, because under plus 0 is the identity. Also R comma dot is a semi group. If it is semi group means R satisfying the closure property, associative property under dot. Then one more property. I am taking 3 elements belongs to R. Okay, so combine the two operations together, dot and plus. So 7 dot into 9 plus 10. So how it is splitted, 7 dot 9 plus 7 dot 10. Answer 133. Or 9 plus 10 into 7. So 9 into 7 plus 10 into 7. Both answers is what? 133. So this type of property is called dot is distributive over plus. Dot is distributive over plus. Okay, if the set satisfying this above all the three, then the set is called ring. Okay, so R comma plus comma dot is called ring. Okay, R comma plus comma dot is R comma plus is a abelian group with 0 as identity. Also R comma dot is a semi group. Also dot is a distributive over plus. Among all the three, the set satisfies the ring condition. Also, I am taking the any two elements belongs to R. 7.9 equal to 9.7 equal to 63. This property is called commutative. So R comma plus is abelian. So R is commutative under plus. But here R comma dot is semi group only. We didn't say that R is a abelian. Only semi group. It satisfies two conditions only. If R is satisfies the commutative, then the above ring is called commutative ring. Now one more one. 7 comma 1 belongs to R. I am taking the inverse element, identity element. 7 into 1 equal to 1 into 7 equal to 7. Here existence of identity. So here ring with identity. Okay. Now I am taking R comma plus dot is a commutative ring. That is R comma plus is a abelian group, R comma dot is a semi group, dot is distributive over plus. Along with R comma dot is a commutative. Okay. So from the commutative ring, I am taking two non-zero elements A and B. What happened? A dot B equal to 0. Then A and B are called zero divisor. Okay. So mostly non-zero elements, product of the non-zero elements never be equal to 0. If the product of non-zero elements equal to 0 means zero divisors. See one example. I am taking Z6. Under modulo 6, we have the set of elements 0, 1, 2, 3, 4, 5. I am taking two non-zero elements 2 and 3. 2 not equal to 0, 3 not equal to 0. So 2 into 3 equal to what? 6. But under modulo Z6, 6 comes 0. So product of two non-zero elements equal to 0. That is called zero divisors. Now in commutative ring, any two non-zero elements such that A not equal to 0, B not equal to 0 and A dot B not equal to 0, then the ring is called without zero divisors. So A not equal to 0, B not equal to 0, A dot B equal to 0, zero divisors. A dot B not equal to 0 without zero divisors. Now we are taking the commutative ring. Commutative ring with the unity or identity without zero divisors is called integral domain. Clear? Integral domain is a commutative ring along with unity without zero divisors, and a commutative ring with unity or identity, and every non-zero element has multiplicative inverse. From the set r comma plus comma dot, taking every non-zero element, all must have the multiplicative inverse. Then it is called field. Then it is called field. So clearly we have identify what is the difference between the integral domain and the field. See, every field is an integral domain, but any finite integral domain is called field. Okay. In the next video, we will see the example of field, how we identify the integral domain and the field, then problems based on the field. Okay. Thank you.